Today we're going to learn how to find the volume of a pyramid. Please be open to page 384 in your textbook and have a piece of loose leaf paper to take notes as we go through each example. We can find the volume of a pyramid by thinking of it as finding the volume of a prism with the same shape base and just multiplying it by 1/3. And so you'll see the formula is V equals 1/3 times the area of the base times the height of the pyramid. In each of the examples today, you will be given the height of the pyramid, which is the perpendicular distance from the base to the vertex. Unlike the slant height that we've been working with surface area, the height of the pyramid is like an imaginary line extending from the vertex into the middle of the pyramid. Take a look at example 1. They give me a hexagonal pyramid. And just like we did with the area of the base, they give me just like we did with the surface area of a pyramid, they give me the area of the base. And so I can simply think of the formula V equals 1/3 times the area of the base times the height. Well, the area of the base is 48 and the height of the pyramid is 9. And so I simply multiply 1/3 times 48 times 9. I always want to look for relationships like numbers that are divisible by 3 because I'm multiplying by 1/3. So I would look at this and say, well, 9 divided by 3 is 3 times 148 would give me 144. I could also plug it into my calculator as 48 times 9 and then divide by 3. Just be careful not to use 3/10 or any rounded form of 1/3 or you won't get an exact answer. Don't forget a label. It would be 144 cubic millimeters or 144 mm cubed. In example 2, you have 2 examples of pyramids where you would have to find the area of the base. So in example 2a, we can think of that as the same as a prism with that shaped base or a rectangular base in which we used length times width times height. So we can think of 1/3 times the area of the base, which would be length times width, times the height of the pyramid. If you're more comfortable with just thinking of it as finding the volume of a prism and then dividing by 3, that's okay too. I simply plug in what I see. The length and width are 4 and 3, and the height of the pyramid is 7. Again, I can see that 3 is divisible by 3, so it's kind of like 4 times 1 times 7, or 28 cubic feet, or 28 feet cubed. In the next example, we have a triangular pyramid, and so I have to use the formula for finding the area of a triangle, or 1/2 base times height. What makes this confusing is we have the height of the triangle, which in this case is 6 meters, that makes up the base, and then we also have the height of the pyramid that you see here that extends up to the vertex, which is 10 meters. So just be careful when you're substituting in, when you're finding the area of the triangular base, it should be 1/2 times 17.5 times 6. That 10 should be at the end because it's the height of the pyramid. In this case, I have 1/3 times 1/2. So if I want to think of that as 1/6, and I think of 1/6 times 6, again, that's 1. And I can just multiply 17.5 times 10 would give me 175 cubic meters, or 175 meters cubed. At this point, I'd like you to complete numbers 1 through 3 on page 385 on your own, and then resume the video when you're ready to check your answers. In number 1, you have a pentagonal pyramid. Again, we start with volume equals 1/3 times the area of the base times the height. They give us the area of the base is 21 square feet, and they give us the height is 6. Both of those numbers are actually divisible by 3, so I can actually use either and think of it as 1/3 of 21 is 7 times 6 is 42 cubic feet. In number 2, we have a rectangular pyramid, so I'm going to use that length times width times height, or 1/3 times length times width times height, and substitute in 1/3 times 10 times 8, and the height of the pyramid would be 7. In this case, those 3 numbers are not divisible by 3, so I'm going to end up with a mixed number. All of your answers are either going to end up being a whole number, going to be a mixed number including 1/3, or a mixed number including 2/3. When I see this answer in my calculator, it looks like 186 and 6/10 repeating, which I know is the same as 2/3. So I'm going to write it as 186 and 2/3 cubic inches. If you were to write this as 186 and 7/10 or 186 and 6/10 repeating, that would be okay too. In the last one, we have a triangular pyramid where they give us the base and height of the triangle are 18 and 7, and those can be switched around. We can think of it as 7 as the base and 18 as the height, but the important part is we're using that 1/3 times 1/2 times 18 times 7 times the height of the pyramid. That 11 should be at the end of the substitution. And so when I multiply all those together, I end up with 231 cubic centimeters. I hope you did well with the review problems, and this concludes the lesson.